Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Seamless data integration into AI applications often falls short, leading many to adopt RAG methods, which come with high costs, complexity, and limited scalability. Cogni offers a better solution with its open-source semantic memory engine that automates data ingestion and storage, creating dynamic knowledge graphs from your data. Cogni enables AI agents to understand the meaning of your data, resulting in accurate responses at a lower cost. Take full control of your data in LLM apps without unnecessary overhead. Visit aiengineeringpodcast.com/cogni, that's COGNEE, today to learn more and elevate your AI apps and agents. Your host is Tobias Macy, and today I'm interviewing Viraj Mehta about the purpose of an LLM gateway and his work on TensorZero. So Viraj, can you start by introducing yourself?
Yeah, sure. Hi, I'm Viraj. I am the CTO and a co-founder at TensorZero, and I'm really excited to be here today to tell you guys about how we think about AI applications and our product and the open source software that supports it.
And do you remember how you first got started working in the ML and AI space?
Yeah, sure. So I started computer science more generally, like when I was a freshman in college and like had only had limited experience programming with that. But I got quite bored during my second summer internship. I was at Google and I like finished some of the software engineering work that they'd assigned me to do. And so I spent a lot of time that summer running around at Google where there are a ton of really interesting people and trying to, just chat with folks that I thought their jobs were cool. And what I realized was that kind of observing the patterns in my own interest, that a lot of those folks had done machine learning work and were doing machine learning work, even if I didn't realize that, at the time the Google self-driving car project at X was heavy on machine learning, or that the generative music project was heavy on machine learning. I post facto noticed that. And then I also realized that all of those folks had research backgrounds, and in particular, like most of them had PhDs. And so having like noticed that about myself, when I went back to school, I got involved in the vision lab and started working on things like 3D vision and robot grasping and some of those techniques out of the Stanford Vision Lab. And at that point, the bug got me that AI research is awesome. It's so fun. It's an unbounded and like fractally interesting problem, and it touches so many different layers of the stack of computing. And I really enjoyed those aspects of the problem. And so that is a bug that hasn't left since. That was maybe 2016, I think.
And so that has ultimately brought you to TensorZero. But before we get too deep into what you're building specifically, I just wanted to get an understanding about what even is an LLM gateway and what is its purpose in the overall architecture of an AI application.
Yeah, sure. So the way we think about an LLM gateway is that it is a server that you might stick in between all of the client-side application code that does all the normal things an application does, and the set of AI models out there that you might be interfacing with. And so whether those are external, third-party API providers that serve LLMs, you can think OpenAI, Anthropic there, or cloud providers like GCP, AWS, Azure, or your own self-hosted application or LLMs, like things you might run on your own GPUs, such as like VLLM or other competitors there. You want a centralized place where if your application code needs to talk to an LLM, it can make a request to one place and then it gets routed to the right downstream LLM server. And it also does a lot of the bookkeeping and standardization and observability and a lot of the other stuff that makes that happens all in one place, so that you don't have to do this all over your application code. And so a gateway server is a nice way to do all of those things, and also manage the credentials so that you're not sending your OpenAI API key to a bunch of different places where your application might want to call OpenAI from.
And in terms of that LLM gateway functionality and its role as a centralized proxy for being able to actually interact with the LLMs ultimately, what are some of the different types of features and capabilities that you might expect from that type of a service? And what are the opportunities that it provides as a sort of choke point in the architecture to be able to add additional features or functionality or value added utility?
Yeah, sure. So I'll start with the general case, and then I'll talk about how we depart from maybe the standard architecture. I think the thing, the at minimum thing that you want, and this could be provided by a client library or by a gateway server. And I think like LLM made the smart design decision of saying, okay, like we're gonna give you the option. So when you're developing, you don't need a binary that's working somewhere else. You can just directly call LLM APIs, and then as you move to production, you can have the actual server. But regardless, you want to be able to call many LLMs without having to change your form of your request to match the expected interface for each of the providers. And for some of the providers, like most of the providers are in some way OpenAI compliant. And so you could use the OpenAI client to talk to VLLM and SGLang and some of the APIs exposed by Google, but not most. But you wouldn't be able to call the Anthropic family of models. And one of the other things that's like more tricky is like even within the broad umbrella of things that look like OpenAI, there are a lot of small differences of how each of the individual providers work. And so further desiderata for an LLM gateway type application is that it does some rationalization of all the features that like may or may not work amongst all the different providers. And so, for example, you may want your return type to be JSON. And that's a common thing that people want from LLMs because obviously you want machine readable output and so on. And so some providers don't support JSON, but they do support tool calling. And OpenAI, I believe, was like this for a while, but now one like example that just came up for us was that TGI supports the tool mode where you can actually get like a guaranteed JSON with they claim they have a guaranteed schema, and so you can actually do the thing you want and get JSON out, but they don't explicitly support JSON mode the way OpenAI does. And so one thing that you might want from your LLM gateway providers, if I'm using the TGI backend and I'm actually routing my request to my own model that runs on TGI, I want you to transparently, without my application code having to think about this, when I ask for a JSON, know that the only way to get a JSON out of TGI is actually to pretend this is a tool call and then force the model to call that tool and generate the correct arguments for that tool, which then we munge back into, oh yeah, here's your JSON, have a nice day. And so those are the kinds of features that are like table stakes for an LLM gateway to just make the downstream provider set look exactly the same to you. Some other kind of software engineering style features that you're going to want are things like configurable retries, load balancing, fallbacks, that sort of behavior, so that your application doesn't have to think about, well, there are 6 different places that I can call to get an implementation of Llama 70B. We have API keys for all of them, but like maybe we should try them in order of cost, so ascending order of cost. So if for example, the cheapest endpoints are available, we'll use those. But then, maybe there are higher cost, more high availability endpoints that we would want to try lower in the stack of choices. And so we'll get to those if the first few requests fail. And so that's another feature that's like super common, and I think most people really like about LLM gateways. And then I've talked to people who work at large organizations where they've implemented their own internal API gateways that also do some sort of like request prioritization or accounting stuff. So, oh yeah, we have like internal keys that map to different budgets, and we want to know which organizations are actually responsible for how much traffic. And so we want to do that kind of bookkeeping at the gateway layer as well.
From an application perspective as well, it seems that the gateway could be a natural point to do things like request response caching to say, okay, this request is fundamentally the same as this other one, so we're just going to return the cached response rather than send it all the way to the LLM and deal with that latency and the cost, as well as some of the audit logging, etc. And I know that you have some of that in TensorZero, so maybe this is a good point for us to talk a little bit about what it is that you're building and some of the story behind how you came to TensorZero being the thing that you wanted to spend your time on.
Yeah, totally. So I think, especially, I think, so I forgot caching. Caching is like another, we don't have that supported in the product today, but a lot of the gateways do, and it's a obviously valuable source of, you can save on tokens and save your time. There's also kind of on caching more broadly, a lot of the API service, this is a tangent, I'll answer your question in a minute. A lot of the API services also implement things like request caching on the KV cache layer of the transformer backend. And so you want to at least optionally allow your customers to do things like, if, for example, for OpenAI, this is automatic, but for Anthropic, you have to actually turn on some flags and things to get that behavior. And if you optionally want that behavior, it would be better if that was centrally managed rather than every single time you want to call an LLM that might be Anthropic on your application that you have to like send those flags in. So it's another place to like do that kind of global settings management of how you ought to interact with like the external providers. To TensorZero. So I come to TensorZero from like a very, very different perspective than probably most of the folks who get involved in LLM gateways. So I did, before I was working on TensorZero, I was wrapping up a PhD at Carnegie Mellon where I was thinking about reinforcement learning quite a bit. And so that started very far away from LLMs. I was working, on a Department of Energy research project where we were trying to use reinforcement learning to improve control of plasmas in nuclear reactors, which is a whole other long topic that I think is like amazing. I could talk about forever, but I'll stay on topic a bit. The key consideration with that problem, though, that like eventually led me to language models was that this data was unbelievably fabulously expensive. Like you can think, like a car per data point, like $30,000 for 5 seconds of data. And so that problem leads to a huge amount of concern about, okay, like we're going to only get to run a handful of trials per trial. Like what is the marginally most valuable place we could collect data from in the configuration space of the tokamak? Like where should we initialize the problem? What should the policy do to collect the most valuable information? And so got really interested in this, like if we're going to pick a single data point from a dynamical system to inform an RL agent, what would the most valuable data point be? And so I spent most of my PhD thinking about problems like that and like applying them to nuclear physics stuff and nuclear engineering stuff. But then at the end, I realized that, oh yes, like we've developed a lot of machinery for data efficient reinforcement learning. And some of this machinery applies quite well to the techniques that they're now using to align language models. So I wrote a paper about if you're doing this standard setup for reinforcement learning from human feedback, you are trying to make a query of like, okay, here's a prompt, here are two completions, and a human is going to tell you which completion is better. And you want to use that information to improve the performance of your downstream language model on like a distribution of questions humans ask. And so the question that we asked was, all right, let's say you had one more label you could get from a person on this. What would be the prompt and which would be the completions for which you would like want to use that last data point for, so that you can get the best improvement in your policy? So we came to a theoretical solution for that, which the setting is called contextual dueling bandits, but I don't know if that would mean much to anybody. And so we came to a theoretical, like, oh yes, this policy would return like a good, would do well in that theoretical setting. We implemented it for first like a simple toy problem with like that same thing, and then we said, okay, this actually, one neat thing about this algorithm by design is that it actually works for real techniques that we would use to really train language models, and in that case, it was direct preference optimization (DPO). And so we actually implemented that for language models, and that got me really kind of thinking about the language modeling problem from a perspective of reinforcement learning. And I think that has become a lot more popular today. We hear about RL a lot more, especially since the O1 release in September. But back then, this was maybe late 2023, it was a little bit more heterodox to think this way. And so we were like, one thing that was really obvious to me as I was deciding to start this business with my co-founder Gabriel, that LLM applications in their broader context feel like reinforcement learning problems. And so let me unpack that a little bit and how that gets me back to gateways. So first off, like one generic model of a language model call in an application is that you have some business variables in your code. They're probably, ints and floats and strings and that kinds of thing. And then you arrays thereof, like a JSON. And you take that JSON and you template it into some strings. So you have now like an array of strings. You send that string to OpenAI or equivalent. You get back some more strings or another string, and then you parse that string and you do more business stuff with it. And then maybe you make more language model calls like that down the line. And then eventually some business stuff happens and like either it goes well or it goes poorly. And usually this feedback is going to be noisy and sparse and, maybe natural languagey and not really quantifiable, but like you can get something back maybe, hopefully. And let's assume that you get something back for now, and then I can unpack, like we can talk about the industry and whether this is like, generally true. But what this looks like then is you make many calls to some machine learning model and you have variables, structured variables on one side, you have structured variables on the other side, and then you have like stuff that happens in the middle. You do this many times, then you get back some reward. And this looks to me like a reinforcement learning problem. Maybe I'm biased because I've spent a lot of time thinking about things that way, but I'm like, this does smell like a partially observable MDP Markov decision process. And so I was like, we kind of took this really seriously back in the early part of last year, and we actually wrote down like in math, like for real, what do we think the mapping is between like the standard design of an LLM application and a POM DP? I'll write a blog post about this soon, and so we can share it with folks. But that led us to the idea that okay, really the policy here, which is like the thing that makes the decisions, is the entire function that is inside of the business variables on the input side of the call and outside, before the business variables on the output side of the call. And so what we realized is like, okay, our interface design is going to be different than OpenAI's interface design. Because OpenAI, due to the limitations of their system and the design of like how they're serving you a model, they take strings as input, and then they take, they give you basically strings as output, and that makes sense for them. But I think like for applications, the right way to think about talking to a language model is like, oh yes, I'm going to design a input and output signature for a job that I would like done by something smart, and then I will make that typed function call, and I don't really care what happens under the hood at all. What I want is outputs that lead to good business outcomes down the line. And so obviously that's not sufficient to like get started. You need to go under the hood and like write a good prompt and try it a few times and make sure it's sensible and that it won't do anything crazy upon deployment. But then once you have something reasonable going, really your goal is like, okay, now we have something reasonable going. Let's optimize against whatever feedback signals we have or the comments that the PMs make about the performance of the system or those kinds of things and try and do better over time. And so that to me also looks really very, very much like a reinforcement learning problem. And so from there, we realized, okay, if we were to build an LLM application ourselves today, I would probably take these insights and use that to, treat the application code as making these type of function calls and then have the ML process be, okay, we have like this incumbent implementation of the function call that was the original prompt and like whatever model you originally chose and so on. And then the job of like an ML scientist or MLE who's working on the team is like, let's repeatedly improve the implementation, to come up with new implementations that might be better than our original implementation and actually like slot them in or A/B test them against the original implementation to see, is the new prompt model generation parameters triple that's like actually implementing this function call going to be better. And so I think for us, that led us to, okay, well, we need to clearly, where are we going to insert this into the stack? And it made sense that it would be, oh yeah, like one of the design variables, obviously, of trying to come up with new implementations of a function is you're going to maybe want to try different language models. So like, well, obviously it makes sense to then insert into the stack of like all LLM applications at the point where you have the choice of different language models. And so we optionally, I think, and we're one of the few products that does this today, and I think we probably have the most articulated and like explicit view of how this should work, is the prompting. We want to also manage the prompting. Like you can use the product without like and keep the prompts in the application code, and a lot of people do this. Like you just build your strings out of Python F strings or with JavaScript or so on. But if you can keep the prompt in the gateway layer, what that means is that you're able to at inference time say, I want to call Anthropic with prompt A, or I want to call OpenAI with prompt B, or I want to call Gemini with prompt C, or I want to call my fine-tuned llama that doesn't need much of a prompt because it's been fine-tuned on so much data and it knows what the problem is already with minimal prompt D, and like let's compare those. And I think that because language models, like different language model families, should be prompted differently, and because you really, when you're thinking about the performance of a particular implementation of your LLM function call, you care about the prompt, like the whole function. You don't care about just the model. Like this is like a nice unit of abstraction for application code and for people who are monitoring these systems. I just talked for like 10 minutes. I'm sure like you have questions.
No, that was great and very useful. And to the point most recently that you were making about automating some of the prompting, it puts me in mind of another project framework that you may or may not be familiar with, of DSPy, which I think came out of maybe Stanford. And I'm wondering some of the ways that allowing something whether it's DSPy or TensorZero, to automate the prompt generation, how that shifts the way that you think about the overall design of your application, where the LLM is some core piece of that functionality, and just how you've seen teams try to tackle that of, oh, I've spent all of this time on prompt engineering, I've got the perfect prompt. Oh, wait, the prompt started falling apart because they released a new iteration of the model. And just so some of the ways that they think about the role of prompting in the overall application stack and the behavior thereof.
Yeah, I think DSPy is, I think it's a really cool idea, and it was definitely one of the inspirations for me as I thought about this. And in fact, right during that time in late 2023, when I was thinking about this in the very early days, I actually emailed and hung out with Omar at NeurIPS, Omar Khattab, the author of DSPy, at NeurIPS, and so we talked about this then. And I think one way to contextualize the relationship between TensorZero and DSPy, where we actually do, there's an example in our repository of using DSPy to optimize prompts, is that TensorZero is production software that collects data that is well structured to do all kinds of things to improve your implementations of all your function calls, let's say. And these, DSPy is one set of techniques, because they have many optimizers as well, that can read from the data model that we're storing and write essentially a new implementation of one of these functions to our config model. And then you can A/B test it or evaluate it or do whatever you want with a new implementation. And so DSPy is one way to, I think, one really smart way of thinking, prompts are LLM applications are programs, and we should think about this as a composable kind of PyTorch style graph of LLM calls and dependencies, and then we can quote unquote back propagate through that graph as in a PyTorch kind of way to improve the language model calls that happen upstream. I think we think about this very similarly. Maybe some of the differences are that DSPy is it doesn't really manage data. It thinks about, all right, you hand me a data set and I will run optimization, but the accumulation and structuring and labeling and that whole part of the problem is external to DSPy. And so you need, if you're going to do this on hand curated data, then you can hand curate your data set and hand it to DSPy and see what kind of prompts it comes up with or so on. But if you're going to do this as part of your production system, which I think is especially as LLM deployment scale, the right way to think about this, then you need a tool like TensorZero that's going to, in a structured form, dump all the information that you need to then do DSPy later. And I want to be super clear about it's actually really hard to get this data model correct. For example, most tools in the industry that are doing LLM observability, including many of the gateways, they're going to dump the strings that you send, because they don't have this concept of, okay, I have typed input gets templated into strings that then get sent to an API. You're looking at the strings that go into the model and the strings that come out of the model as your data set that you're storing in your observability platform. And in doing so, it means that down the road, I've changed my prompt 6 times over the last year, and I want to fine tune on the historical data that ended up going well. In order to make sure that all the data has been templated with your last prompt, you have to parse out or go get the variables from somewhere or retemplate. That's either going to be a difficult parsing problem, or you have to go and ETL it or do some join with some external system, or you have to, it's hard. Whereas if you just store structured information about what went in, then it becomes easy. It's okay, yeah, we just retemplate everything, we have it in this other table. And so there are considerations like that, along with the fact that you want to know these are the different types of LLM calls that led to some downstream outcome that force you to kind of think about the data model in roughly the way we think about the data model. I spent a lot of time. I think that was the thing that we spent the most time on last year, was thinking about this and making sure that the entire universe of things that we would want to do in the future was supported by the data model. And now I think we're really happy with having a forward compatible data model that lets you run TensorZero today and know that in the future, as we start to implement more optimization techniques, which is kind of the direction we're turning to now, that they will be compatible with the data you collected last year.
So digging a bit more into TensorZero and its overall architecture and system design, I think that that will be useful to frame the rest of the conversation about its features and functionality and workflow. And so, just I guess if you can give a bit of an overview about how you have implemented TensorZero and some of the supporting infrastructure that it needs to be able to do this operation of storing the structured inputs and outputs and then performing optimization on that.
Yeah. So first, like I'll talk about, I guess, a user's perspective on this rather than a system administrator's perspective on this, and then because that system administration is actually not too complicated. So as a user, you think about like if you built your application with OpenAI, let's say, and how would you move it over to TensorZero? You would and do it correctly because TensorZero does offer a drop-in OpenAI compliant endpoint, so you can just point your endpoint at TensorZero and start using it. But to do it properly, let's say I would think about, okay, what are all the jobs in my application which are done by LLMs? So what are all, if I had a bunch of smart typed functions that I would be calling, like what would they be called? And then like where would they be called in the application? And then, okay, what would the input variables look like? And ideally write down like a JSON schema of that. And what would the output signature look like? And so are there tools that would be called? Would there, what do we want JSONs out? And like, what would the schemas of those be? And then that allows you to go and configure, okay, we have a toml configuration file where you write down, here are the functions that I'm calling, and here are the inputs and output signatures, and pretty quickly replicate, okay, now I have an OpenAI, I have the same thing that I was doing with OpenAI, but now I've factored it out into the jobs that are being done, and also like put structure into, okay, here are the input variables and here are the output variables. And so now that TensorZero comes in as it's a client that you pip install or you make web requests to, and there's a binary basically that's a Rust binary that sits. It's a Docker container you can deploy anywhere you deploy your Docker containers. That is stateless, but it reads the configuration so it knows what is going on with like what are the functions that are going to be called by the client. And so everywhere in your client code where you're calling LLMs, you're calling these functions. And so now the ClickHouse gateway will route, implement the functions by taking the variables, templating, and then shipping them off to the appropriate language model provider, and then returning the responses and parsing and validating and so on, and implements things like fallbacks and retry. It does all the things. But the other thing that it does is it dumps the other basically dependency that it sits on is ClickHouse. And so you would like to have ideally like some sort of deployment of ClickHouse. So whether you're using the cloud service or your own open source deployment or however, you want a ClickHouse that where this data starts to be materialized in a structured format. And so what that buys you is after you run this application for a while, and important to add, the TensorZero Gateway also has a feedback endpoint. So we support Booleans, floats, comments, and demonstrations. So if there's like a human in the loop that actually edits a response before it goes out, you can send that response as a demonstration of the desired behavior. But then what that gives you is a ClickHouse that's full of the interaction history. So what were all the inferences that were part of a particular LLM, like run of your application? And then how did it go? And that allows it, that's a really useful data set for optimization. So we can start to then run, do things like let's curate the data based on which ones went well, template them to our latest prompt, and then fine tune a smaller model, either like a Llama series or an OpenAI series or one of those kinds of things. And then let's slot that in as a new use that model now, slot it in as a new implementation of our language model call and run 5% of traffic through it. And so all that really takes is we have a web UI now that reads from ClickHouse that it's another Docker container, and you can like go in the UI, look at your inferences. There's a form for fine tuning, although we also publish notebooks that do this, and it will curate by the metric, and then you can pick which template you want to use and which model you'd like to fine tune, and then go, and it gives you out a toml block that you add to your config, and now you have a brand new model that you can run an A/B test against. And so it tries to, and then all of that data is continued to be, dumped to ClickHouse, and you can see like how is, variant A, your incumbent variant, doing against variant B, your new fine-tuned model, and you can make a determination as to like, all right, how are these confidence intervals on this metric, and are we able to actually like, is it worth flipping over to the new model? And so, did that make sense? Was that clear? I know it was again a lot of text.
That makes absolute sense, and I think that is definitely a very interesting and useful aspect of the system is that it does maintain that history in the ClickHouse database for that feedback. And one of the questions I was going to ask, which you proactively answered, was how that human feedback gets factored in and what are the interfaces available for being able to then provide input back to the application and TensorZero to say, yes, this is what I want, or no, this is really bad. And so the fact that you have the web UI is definitely very useful for some auditor or some administrator of the system to go in periodically and say, okay, these are the things that we like, these are the things we don't like. But it also gives you the opportunity to expose that in your client interface, where even
Yeah.
if it's just a thumbs up, thumbs down of this was a good response or this was not helpful, and then being able to feed that back into the system as an automated feedback loop without necessarily having to have that be a manual task by one of your teammates on whatever periodic basis.
Sure. And a quick digression. I spent a while 2 years ago before TensorZero thinking about like, what if you were to acquire a services business and use LLMs to like start to automate things, but like you don't want to like degrade the quality of service of the services business. So you would have humans review the humans like still review all the work that the LLMs are doing and fix it. And that would eventually generate a training set to improve the quality of your LLMs. And I didn't end up doing that because I'm not a private equity tycoon. I was a grad student at the time, but I was thinking that through. And what I landed on was like, for many businesses, like it's going to make sense to have this. Okay, the humans are continuing to like audit the LLM output for a long time, and what you really want is like the frequency at which the auditors have to change anything goes down over time, and that means you're getting closer to your eventual goal of, I guess, automating the job or decreasing, increasing the productivity of labor. Let's put it nicely. And so there's like this natural, okay, well, we're going to get demonstrations of good behavior as we're doing the handoff from humans to AI for this menial job. And that you need to be able to take account of that information. That's the only way this transition ultimately ends up happening. And I think like, even as the base models get smarter, so that will continue to happen for sure. There's like too many smart people and too many dollars and too much compute being thrown at this problem. It doesn't necessarily mean that the models will be getting better at your particular business task. So, for example, like I don't know that since the GPT 3.5 series, the models have gotten quite a bit better at like writing very targeted sales emails. Like I think you just have to learn what works. In my experience doing any kind of sales or marketing, like you have to learn from trying stuff, like what works for your particular kind of customer population and like what works for your particular product and like what are the hooks that actually like do the job well. And if you could do it contextually, that'd be great. Nobody really can. And so I think there are still plenty of business problems where you want to take advantage of the production data in order to do better, even as the models get stronger.
Another interesting aspect of what you're building with that ClickHouse record keeping is effectively the interaction history of at least the application with the LLM. Another core capability that is built into a lot of the chat based applications, or that people want to have built into their chat based applications, is that keeping of history of what are all of the requests and responses for a given user, and how do I also use that to enhance my profile of that user to then be able to give them more useful responses and maybe be able to feed that into the context of the request that I'm sending. And I'm curious how you're thinking about the role of TensorZero in that use case, or LLM gateways more generally, and some of the ways that that factors into the overall system architecture of what is the piece that owns that. And another aspect of this is the idea of memory that is being built into a number of other products, whether they are part of an existing framework or an addendum to the overall stack. I'm thinking of as far as like Cogni, Mem0, the LangChain or LangGraph memory capabilities.
I think this is a really interesting kind of distinction to make, that we have like we're probably on far on one end of the spectrum here, so it's an interesting perspective with which to regard it. Let's for a second, just for completeness, I want to rule out the new architectures that have been coming out lately where the during inference the weights the model, or like some memory is baked into the weights the model and instead stick to okay, the model is like memoryless, and we're not like baking dynamically new things in. So if we leave that out, I think that the concept of memory in LLM applications boils down to let's try and it's a context that's writable. It's a context store that's writable. So the idea there is like even like the ChatGPT implementation, I believe, is like ChatGPT has the option of saying, okay, this is a good piece of context that I would want to return to in the future, and writes it to some store on OpenAI's server side. And then in future conversations, that context, that memory is put into context along with, the user question at the time. So to me, I think about this kind of similarly to RAG in that, or retrieval augmented generation, in that you have like some store of documents that might be useful for making an inference, and you retrieve the most relevant ones prior to your inference time. I think like user specific memory writing is like if you had a vector database, for example, it doesn't have to be, that is writable with the with optionally writable by the context of by the LLM as it's making the conversation, and then future inferences can read from it as part of that memory stack. And so when I look at the products that are out there from LangChain and from MZero and from some of these other providers, that is usually the architecture that I see. For TensorZero, we don't really we're primarily focused with like what are the things that we can use to improve the actual LLM calls, and so we don't actually deal with this very much at all because we think that for a well-designed LLM application, like you're going to want to like probably the design of your memory is like very application specific, and so some things you might want to share among groups, and some things if it's a team setting or an enterprise application, some things are very personal and you want to keep that to the user. And it was we kind of explicitly were like that kind of thing along with RAG are things that are not worth touching today because we are for example for RAG, like the data architecture of a particular enterprise application is going to be highly different very different from the next one over. And there's not a lot of patterns that we wanted to generally impose on how people store and retrieve their data. So we kind of explicitly left it out of the scope. So the way we would treat it is, add a field to the input signature of your function that takes memory, and then optionally send it as your memory system dictates you do. And we haven't really handled that, but we would integrate well. That would integrate fine with any other memory provider. I think, because the gateway layer is such a good choke point for dealing with the general behaviors of LLM applications, I think other people have taken the other approach of no, we're going to have a batteries included solution where we can offer this either vector store or append only memory context document or other memory system there that will know about like your application and know which memory to load into context prior to making the request. But we thought that our decision was that was something that developers could figure out on their own.
Aside from the more detail-oriented memory capabilities, even just for the history tracking of what are all the requests and responses that have happened in historical conversations, is that something that you would presume people would rely on TensorZero's history tracking to take care of? Or would you say you have your own history tracking for user conversations and you can load that in? We're keeping history for a different purpose and they don't necessarily want to mix together.
So we don't like offer client side retrieval for this purpose. We do keep like comprehensive and like at many layers of specificity, like documentation of like what exactly went in and out of the language model, and in particular they're retrievable, and we give the client an episode ID, so you can go and query what were all the inferences made for this episode ID ordered by time. And so that is the right, like you don't need an additional store to go ahead and actually get that information. So it's not, we haven't seen folks use this as, I guess we don't know exactly what everybody's doing because we don't have telemetry built into the product, but like it is totally valid, and we publish the data model, and it will be, ClickHouse is like a perfectly fine database for that sort of thing. And so it is definitely, we keep the data in a useful way to do that, and we give you the tools to be able to retrieve it if that's what you want. But we haven't marketed it as such. So I think, yeah, I hadn't considered it from that angle before, but yeah, it's totally possible with the product.
You mentioned that you don't have telemetry built in, so you don't have that tracking of how users are using the application, which is definitely, I think, a desirable trait in an open source project. I'm wondering how you're approaching the long term sustainability and overall business model of what you're building at TensorZero, and how you think about what are the capabilities that belong in that open source core application, and what are some of the additional functionality and value add features that you're looking to build over time as you kind of grow the capabilities and grow the organizational capacity.
Yeah, so I mean, we're still early. We're lucky enough to have investors who are aligned with the kind of longer term vision that I'll present in a second. And so we're not racing to make money, and we're not even really building anything that's not going to be part of the core OSS today. But we do have a clear design and a line for where this is drawn, and we're happy to share that. We share that with anybody who asks, because like we think this is part of insurance against rug pulls for folks who want to depend on the open source package. So the way we think about this is like from the beginning, and actually the original version of TensorZero that we were running last year as we were trying to figure out what we were going to build was a managed service. So we were running this gateway as SaaS. A couple of folks would integrate against it and send feedback to it, and we would store the historical data on our side. And then we had this man behind the curtain, Wizard of Oz style. Okay, we're going to run the optimization techniques mostly manually. Like Gabriel and I are both been doing ML a long time. Like we'll just optimize your models for you based on the feedback you're giving us, and we have the data set to do it. So, and we'll run the A/B tests, and we'll just make it work. And we were able to get actually quite good results doing that. Obviously, not sustainable from like how much sweat went into doing that. So what we realized was, okay, like we need to be really honest with ourselves here and build a system that even if we weren't there would allow people to make their LLM systems better based on the feedback that was being collected. And so the plan, and we've already done the vast majority of this so far, is let's publish tools that allow you to build your application with TensorZero and collect the data and store it in a way that's useful to us. And then techniques that read from that ClickHouse data model and write like new variants, new implementations of the functions to our config. And so we have a couple of those built. So we have supervised fine tuning with a couple of providers. We have a workflow for dynamic and context learning. We have I think there's an open PR that should be merged today or tomorrow that does dynamic or direct preference optimization. And then our goal will focus to shift towards one, building better UI, and two, let's improve the number of and keep working on these optimization techniques going forward. And so all of that, I think, will be in the scope of the open source project. But there's a natural thing that happens as you scale and these techniques get more advanced, is that right now, the first few techniques have been things that you can run with only an API key and no compute. We wanted to ship those first because that's easy for everybody to run. But of course, right, there are limits to the customization APIs that are available from both the major labs, like the OpenAIs of the world, but also the Togethers and Fireworks that will do their own custom fine tuning stuff. And eventually, we're going to want to publish techniques that we think work quite well that are not supported as APIs by existing players. And so you'll have to, again, as part of the open source, run the recipe. You're going to have to go and rent your own 8x H100 node. That's not cheap, and it's annoying to even set up. And if you want several, that's even more annoying. And then you have to run the technique, and you have to do this. You have to know that it's time, and you have to choose the technique, and you have to do this, and then you have to run the evals, and then you have to put that in the A/B test, and then you have to manage the A/B test, and then you have to, then your application gets better. So it's still less work, way less work than it was before when you were designing the data model and you were, implementing the algorithms, you're going and finding them and making sure they fit and that kind of thing. It's an order of magnitude less work than that, but it's still work. And as these applications scale further, I think this is a lot of work, especially if you imagine an agent that's doing lots of things all day and does lots of different, it starts to get hard to manage. And so we want to go back to the original vision of, if you have been using the open source software and the pain of getting all the GPUs and managing them, and then figuring out which experiments to run, and managing the A/B test weights automatically, and all that stuff is a pain. We want to offer a service that basically starts to do all of this proactively. So, hey, we noticed programmatically that you have you have collected 10,000 more data points since the last time we tried fine tuning, and a new Llama model version got released. Let's proactively run like state of the art filtered fine tuning job and train a new model, and then proactively run your evaluations against it and send you a ping saying, hey, your new model's ready for you. Here are the results. And do you want to deploy it in production? And then click this button if yes, and we'll run our usual A/B test routine. And so what this starts to look like is that the improvement aspect of LLM applications starts to be mostly automatic. And we think like, especially for scaled deployments where improvements in KPIs are really all that matters. And of course, cost is critical. So the more data you collect, the smaller a model you can train to achieve the same performance. There's a lot of work to be doing there all the time. And if we can offer, the tools to do that, but you have to manually manage all the compute and like proactively do all the things yourself, or we have like an autopilot for this, like that's a clear line to draw around the open source project that keeps it healthy and useful, and we can keep contributing to it and like keep making sure that this is like an excellent, great piece of software. But then also for folks who are on the larger end and they have like a lot, this is a lot riding on this application, we can start to make it as good as it can possibly be without a ton of ML effort. And like, those are expensive employees who would be doing that effort.
Yeah, it's definitely a very interesting and useful gradation for a project like this, where, as you said, you can do it all yourself, but eventually you're going to get sick of it, and we'll be there when that happens.
And I think like not just you're going to be sick of it, but also we can make better utilization if you have GPUs, if we're doing it automatically, because we can just run stuff when it's done. And also because we can just run more stuff, because it's able to try things in parallel and like more exhaustively search the space of like tricks you can pull, we should be able to like stack more little wins and get to, I would hypothesize, better performance than like if it were done manually, just due to like the amount of search that can be done over like what are the possibilities here. So
And also, if you have a number of clients who are within adjacent verticals, or who are doing similar enough work, then you can say, oh hey, this looks like something that we've seen before over there. Here's our pre-built fine-tuned model for you to use, and it saves you all of that headache of having to do all the data collection and feedback first, and we'll get you an easy win because we already know enough about this type of problem space to know that this is going to work better for you.
yeah, I mean, we definitely don't want to, cross-pollinate data, but I definitely think cross-pollinating learning is a really important and interesting part of building a company like this, where we'll see a lot of things. We'll do a lot of kind of core research that maybe other companies can't do because their job is like actually building the application, and then ideally share that with everyone who uses the product. I think another analogy that I really like here, kind of going back to your point about it works, but it becomes annoying to maintain at scale, is I think like this is the story of Databricks on some level. With like large Spark clusters and large Delta Lake deployments, like it started out as an excellent, really useful open source project, and then down the line has turned into a monster business because they built something really useful, and then people wanted it at scale, and people don't want the headaches that came with that, and there they are.
Absolutely. And as you have been building TensorZero, working with some of the early adopters and clients, what are some of the ways that you see TensorZero and LLM gateways shifting their thinking architecturally, and maybe some of the patterns where the gateway actually gets in the way because maybe there's only ever one LLM that they're going to call for a very limited use case, or just some of the cases where the addition of the gateway just adds too much cognitive overhead or architectural or operational maintenance.
Yeah, sure. So I can talk. I think like TensorZero has its own particular wrinkles that we're trying to iron out of the product. So I can talk about those specifically, and they definitely cause headaches for people. And so we're gonna, give us a month or two, and they'll be gone hopefully. But then I'll also talk about kind of the general case of this. So for TensorZero right now, we don't have Light LLM has this. We don't have the. We'll fix this shortly. Like a client only implementation of the gateway that keeps everything on the. So you can do quick development with just the client. You also don't have this, before, like one thing about keeping things structured as TensorZero kind of recommends you do for production. If you're doing your quick development and you're changing things all the time, you don't know what variables should go into the function in the first place, then like writing down JSON schemas and like keeping everything templatized and organized and stuff can be more friction than it's worth. when you're originally just like trying to rapidly iterate on like, what do I even put in the LLM, and like, what do I even want out of it? And so for there, like time to getting an inference done and looking at the outputs and like repeating that process a lot of time is really a useful thing for developers. And like right now, I would say that TensorZero is a bit heavy for, and like a bit crafty for that kind of thing. So we're certainly working on removing some of those assumptions and making this lighter. But I would say that is a place in the life cycle of an application where our own product is not amazing yet, and we're working on that. But then I think in general for gateways, I think like maybe this is X TensorZero because we spent a lot of time on this, is like when I use light LLM, there are like little wrinkles of each inference provider that are a little bit different, and they're not really like enforced by the interface, and light LLM doesn't fix it for you. So for a while, this is fixed now, so I don't think it's an issue anymore. But Anthropic won't let you send two consecutive user messages as part of a conversation, and light LLM will just let you do it and then give you a 400, and like you're like, what happened? And then you have to go and figure it out, and it's like you have to dig through their docs, and then you're like, oh, I didn't, like, it's not even that clear. And so there's like this headache of like, because there's a layer of obfuscation between you and this is true of TensorZero to some extent as well, because there's a layer of obfuscation between you and the ultimate service that you're calling. When you're trying to debug things, you have to debug two layers instead of one, and that's harder. So because there's a layer of obfuscation, like it took me a while to figure out like why I was getting 400s. For TensorZero, we like know that, and we just like coagulate the messages and do something sensible and try and get it to work. But that is, maybe that's not the desired behavior. And so even with us, like there is a layer of like, okay, there's somebody else's software between me and what I want to talk to. And so there's value, but there's also drawbacks.
And as you have been building and working with some of the early adopters, what are some of the most interesting or innovative or unexpected ways that you've seen TensorZero applied?
Yeah, so I think it's very cool to see, some of our earliest users. We help them, obviously handhold them on how do you set up this for your application, and let's go through it. I think the thing that's been cool is, okay, like now we're gone. It's open source software. Do whatever you want. And people have been, for example, a lot of people use LLMs as a judge for evals. So like, can you check whether this thing's true? And that's an LLM call too that's done by some kind of application of something. And so might as well make that a TensorZero function as well. And so now we have like TensorZero functions judging TensorZero functions. And like in principle, you could have TensorZero functions judging those and turtles all the way down. And I think that that's really cool because ultimately, like one problem with LLM as a judge is it too has a failure rate. And you have to then independently kind of monitor the failure rate of that. And you have to optimize the failure rate of that. And so if we have a common abstraction that lets us say, okay, like every LLM call is something that we can like treat in this unified way and optimize in this unified way and observe in this unified way, it lets people build things that are, I think it's one of the really beautiful things about computers is like, okay, now we can immediately make it recursive and see what happens when we loop it on itself. And it like feels very Douglas Hofstadter-y. And I'm very excited to see this kind of thing more often, and we'll, build it into the core product at some point. And so, yeah, I thought that was like very unintuitive for me and exciting.
And in your work of building this system, building a business around it, and exploring the overall space of LLM gateways and how they can be used to improve the operation of AI applications, what are some of the most interesting or unexpected or challenging lessons that you've learned?
So I think again, I think this goes back to how easy it needs to be to use originally. Like when you go off into a rabbit hole for a year and you're like, this is the correct theoretical thing that should be done, and okay, like let's try and make it very usable and production grade and so on. We over personally like in our journey we over indexed on production grade. And we're like, okay, like we're going to build it in Rust, and we're going to make it like all configurable through files that you can commit in, review, and Git. And we're going to use ClickHouse, which is like the ultimate scale database. And it'll work when your data you have trillions of rows, and it doesn't matter, and it's like all great. But then making that decision means that the bones are really good, but it also means like now we have a ton of work to like make it really easy to get started with. And like, I don't want want a ClickHouse deployment, and like I don't need to run a Docker container. I just want to pip install something and get to work, and like not write TOML files or learn anything. And so it's really been a big process of all right, like we think we have like some of the highest quality implementations, like most thoughtful implementations of an LLM gateway out there, and but it's like also the hardest to use probably. So now it's time to like go back and like uh, fix all of those things that it was an emphasis thing. There aren't bugs, but like let's go back and backfill and make this now like a really ergonomic tool that you can just like pip install or node install and go on with your life. And so I think for us, we made an explicit like hard right turn, and now we need to like course correct, and we're doing that.
And with ClickHouse, at least, it also offers an in-process option, so you can just run it with pip install, and you don't have to have a full distributed multi-node cluster of ClickHouse to get started on your laptop.
Yeah. Like I mean, for development purposes, and like all of our examples come with ClickHouses and UIs, so like you can run Docker Compose up, and then everything works. So it's not. We have a bunch of runnable examples in a repository where that is there, but still, it's just a little bit more of an on-ramp. And something like DuckDB would have been even better, maybe, where we could have compiled it directly into the gateway or something of that sort. But then we wanted this to work for big multi-node deployments if you wanted to later down the line. And so we had to pick one warehouse to get started with. I wish we could support all of them today, but we're a small team, and so ClickHouse seemed reasonable to begin with.
And SQL is never the same, no matter how hard you try.
Yeah. I wish that every warehouse had the same SQL model, but that's never it. And also, you're going to want to optimize things differently based on whether it's Snowflake or Redshift or ClickHouse or BigQuery or Docker or so on.
And you've mentioned a little bit about some of the future roadmap. I'm just wondering if there are any particular projects or problem areas you're particularly excited to explore in the near to medium term.
Yes, I think I'll talk about this publicly. I don't mind. So I think I'll say this: in order to develop a new technique, like let's say generically, like we have some LLM system, and we have we want to develop a new technique for making that LLM system better from our data model, essentially. And so really what we want in order to do that is a bunch of different problems that cover different problem spaces where we can run a bunch of examples, fill up the data model, then run the technique, and then see how much better it got. And so today that involves, kind of building a bunch of ad hoc scripts that run a bunch of examples for each, set up the environment, set up the example, run a bunch of episodes of interaction, and then run the script for improvement, and then run a bunch more episodes to see how it did. But this is a problem that was solved really, really well in reinforcement learning. So the pre-2015 reinforcement learning community would do the same thing of we need to integrate against a dynamical system, and then there's this bipartite graph of algorithms and dynamical systems, and they would all have to jointly integrate with one another. Whereas then the people over at OpenAI published GIM, and GIM was like this unified interface for, okay, now every RL algorithm integrates against GIM, and every environment integrates against GIM, and now it works. And I think that we're very excited about building something internally and then externally that lets us do research at scale against a bunch of different applied problems, and allows one common integration that lets us, without having to know what the environment is or what the problem is, run a bunch of examples, run the thing to make it better, run a bunch more examples, and repeat across a bunch of different problems. And so I think that research tool will unlock a ton of new progress for us in terms of how are we going to make your LLM systems better. And I'm excited to share that with the community.
Absolutely. Are there any other aspects of LLM gateways or the work that you're doing at TensorZero that we didn't discuss yet that you'd like to cover before we close out the show?
Let's see. I guess we touched on it, but I think it's a really interesting kind of, maybe we didn't touch on this. So I want to talk for a second about how directly the reasoning paradigm and the inference time compute paradigm fits into this process. And I think it's very exciting. So if you look at the work by OpenAI with O1 and O3 and their reasoning fine-tuning offering in beta, and some of the open source work that also looks like this and smells like this, you realize there is what this would look like to me is, oh yes, there's a new type of implementation of a TensorZero function, which takes a lot more time and like runs a lot more tokens, but at the end it's like the same inputs and outputs. And now we have this intermediate computational substrate on which chains of thought are happening, and we should optimize it. We should optimize the whole implementation of that. And I think for those kinds of problems where it's clear that OpenAI and their competitors are mining the world for math problems and leak code problems and IOI problems to solve, you need domain-specific data, or you'd like domain-specific data to make that happen. And so I'm excited for the direction of work that's soon to come. All right, like we have our open source reasoning models. How can we directly customize those on the data that's in ClickHouse and do that in a way that makes our customers model all of our customers' applications better out of the box without all the users of the open source project. So very excited for this.
Definitely. All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
I'm going to take this a different direction than probably you anticipated. The question we always ask people when we meet a new team that's applying LLMs to some business problems, like, what are the KPIs that you associate with your product or your management associates with your product? And I think that there is still ways to go on the management technology of, okay, like we have this LLM system that's driving this business process. It's no longer a curiosity. It's something that we care about for business reasons and we want to provide business values. And so we need to, as a management team, look at the denial rate for the claims that were generated by the AI bot, or the click-through rate of the ads that are generated by the AI bot. And like, I think that style of management thinking actually is like not yet as widespread as I would have anticipated a year or two ago, and is an important part of the story of these applications becoming extremely important load-bearing parts of the world economy as like people anticipate. And so I'm going to, I think, put the onus on the business professionals who interact with AI folks and AI systems and say, like, how can like the management technology of how do we start to measure and optimize and like use these things in a serious way requires some development yet.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at TensorZero and the functionality and features that you are adding to the AI stack to improve the functionality and efficiency and accuracy of these AI models that we're all still figuring our way around. So I appreciate all the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Yeah, thanks. You too.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.